Hey guys, welcome back. In our last class, we learned that the domain of rational functions is all real numbers except for what makes the denominator 0. So any x value that makes the denominator 0 is either considered a point discontinuity or an infinite discontinuity. In other words, there's a hole in the graph or there's a vertical asymptote. Holes can be found when the numerator and the denominator have a factor in common. If the numerator and denominator does not have a factor in common, then we set the denominator equal to 0, and that is considered our vertical asymptote. What about horizontal asymptotes? Horizontal asymptotes only happen in rational functions. Horizontal asymptotes is basically saying, where is our graph heading to? That is, what is the limit as x approaches infinity and negative infinity? I want us to think about what I have in the red box here. I have the limit as x approaches infinity for this function 1 over x to equal to 0. I want you to think about this. Imagine you give me $1 out of $1 billion. You basically gave me nothing. If we graph 1 over x, we will see the graph will get closer and closer to 0, but we'll never touch it. So what I mean by that is keep picking points. When x is 1, your answer is 1 over 1, which is 1. When x is 10, your answer is 1 over 10, which is 0.1. When x is 100, it would be 0.01. And we get closer and closer to 0, but never touch it. That's what we call a horizontal asymptote. It's going to be y equals 0 for the horizontal asymptote. There's also a vertical asymptote here. Set the denominator equal to 0. That's all. What about here? So before I show you the fast and quick way on how to find horizontal asymptotes, I'm going to show you the, technical way of doing it, the algebraic way. What you want to do is you want to find the highest exponent in the entire rational function. It doesn't have to be in the top and the bottom, and it doesn't have to match. You divide every term by the largest x. In this case, it's x squared. So if you come to the green part, I took the 5x squared and I divided it by x squared, the 3x by x squared, the 1 by x squared, and I did the same thing for each one. I then reduced it. So 5x squared over x squared is 5, but this left me with an x in the bottom and an x squared. This is 4. This left me with an x and an x squared in the bottom. So I'm just going to carry that on to the next page. If I apply the limit as x approaches infinity, basically, if you use what I showed you in the red box here, 1 over x or 1 over x squared or 1 over x to the third, or any number over x, these will all go to 0. So, boom, 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 my answer is 5/4. So, this function here has a horizontal asymptote at y equals 5/4. So if you think about it, when we get really large with the x's, none of this is actually going to matter. The only thing that matters is the largest, because infinity is going to affect just the largest exponent, okay? There's a really fast way of doing all of these. If you noticed here, I just took the coefficient of the highest two, and that was my answer. Let's take a look at the highest here and the highest here. I want to find the limit as x approaches f of infinity for this function f of x. The highest here is negative 5x to the 6th, and the highest here is positive 4x to the 6th. A lot of times they're not in order, so make sure that you look for the highest. If you reduce this, then you get negative 5/4. What about here? The highest here is going to be 2x squared. The highest here will be 5x to the 4th. If you reduce this, you get 2 over 5x squared. Isn't that correct? There's 2 up here. There's 4 down there, so it leaves you with 2 down there. Remember what I said. If you have an x or an x squared or x to the third in the denominator, your horizontal asymptote is y equals 0. Okay? So, in other words, the bottom will be growing much quicker than the top, and when the bottom grows much faster than the top, you go into 0. Let's try the next one. 3x to the 5th is the highest, 5x to the 5th. The question you have to remind yourself says, what is the limit as x approaches infinity? What is the limit as x approaches infinity? This is the definition of a horizontal asymptote. So when we go to reduce that, you get 3/5. When you come here, a lot of you are just going to say, oh, -4 over -5. But the question is not asking you about the limit as x approaches infinity. That's why you have to be very, very careful. I'm asking you about what happens at 1. How do we do limits? We just do direct substitution. 5 times 1 squared minus 4 times 1 to the 5th over 4 times 1 to the 3rd, 5 times 1 to the 5th. So you're going to get 1 on top and -1 on the bottom, and so you're going to get -1. So guys, make sure that you understand what you are approaching. When it's infinity, they're basically looking for the highest exponent in the numerator and denominator. In all of the cases except for the last one, we found the horizontal asymptote. But what I didn't show you in the last one was there's a third case where there's no horizontal asymptote. So we said if they match, right? If they match, then the limit is going to be that coefficient, right? So like 5x to the 4th is the highest, 4x to the 4th is the highest, it's just 5/4. We said that the limit, if they don't match, but the bottom is higher, is going to be 0. Well, what if the top was higher? Well, if the top was higher, then we say none. There's no horizontal asymptote, okay? If the top is higher, think about it. It's most likely gonna go up if it's positive or all the way down if it's negative. There's gonna be plenty more in the numerator than the denominator. So those are your 3 cases. Let's try a few problems here. This question says, find the vertical asymptotes of the function. And what you have to do in this case, remember that you have to first factor the numerator, x minus, because you say, what gives me a plus or minus minus? I'll do the minus minus. What 2 numbers give me? 24, that add to a -10, -6, -4, and then factor the bottom. Now look, guys, these 2 cancel out. Therefore, this reduces to, so there's no vertical asymptote. So you cannot set this equal to 0 until you check to see if there's a hole in the graph, okay? So there's none. There's a hole in the graph, and that hole is at 4 because that's what makes this 0. And then you put the 4 back into here, you get -2/3. What about this part here? What is the vertical asymptote? What 2 numbers give me 32 that add to 12, 8, and 4? Ask yourself, can I take out a number? Can I take out a letter? No. Let's see what we can do here now, because you should always factor x squares. So x plus 8, x plus 4, x minus 10, x plus 10. Now, since nothing cancels out, there's going to be 2 vertical asymptotes. So you have to click this, drag down to 2. What makes this 0? 10. What makes this 0? -10. Those are your 2 vertical asymptotes, okay? And then I'll do one more vertical asymptote problem. Let's see. Factor out of 5 and factor out of x. Always ask yourself, can I take out a number or a letter? And once you do that, once again, guys, these cancel out. You're left with 5x over 3. To find the vertical asymptote, you're going to put the denominator and set it equal to 0. But there's no variable that's stuck with the 3, so there's none. I want to go back here. In this case, if they asked you for a horizontal asymptote, it would be 1/3. Do you see that? The highest on top, the highest on the bottom. The highest on top is 1x squared. The highest on the bottom is 3x squared. Therefore, the horizontal would be 1/3 since they reduce. Okay, here there would be none since this is more than this. Here there would be none since this is more than this. Okay, what about a problem like this, horizontal asymptote? Well, all I care about is the highest on top and the highest on the bottom. You don't really have to distribute everything. What you need to do is take the highest from each parentheses. 2 times 5 times 1 is 10. X times x is x squared. 3x times 3x is 9x squared. Therefore, there's 1, and it's 10/9. Or you could sit there and go like this, and then choose the highest and the lowest. I'm sorry, the highest and the top and the bottom. What's the horizontal asymptote here? None. Why? Because 15x squared is bigger than 5x. What about here? 3x times x, remember you have to do all of them. There's more on the bottom. There's more x's on the bottom. So the answer is 0. There's y, you have to put y equals 0. What about the x-intercepts? Write your answers as coordinates. The x-intercept is where y equals 0. So once again, first see if you could reduce before you look for that. So x minus 4, x minus 1. This cancels out. So 1 does not work. X cannot be 1. X cannot be 4. It might be really nice for you to do that. So there's a vertical asymptote at x equals 4. There's a horizontal asymptote at y equals 1, right? Those are the highest. And now you got to set the rest of this equal to 0. So because x-intercept means set the function equal to 0. So 0 is equal to x minus 1 over x minus 4. You cross multiply. You add 1. And now it's telling you that there's an x-intercept at x equals 1. But we already said nothing. There is no point at 1. 1 is a hole in the graph. So you have to click this and do none. So if your answer comes out to be one of the numbers that is restricted by the domain, then you cannot choose it. You have to put none. Okay, let's try one more. What are the x-intercepts and what are the y-intercepts? Okay, the y-intercepts are the easiest. But let's do the x-intercept. First factor. Factor out of 3. What are you left with? Well, 3 can't go into 38. So we can't do that. So we're going to have to try to factor this person out. 3x, x. 80 is probably 10 and 8. The reason why I thought about 10 is because I want to get rid of this. Okay? So that works. And then you're left at 2, 3x plus 8. Set this equal to 0 to find the x-intercept. When you cross multiply, this times this is 0 equals 2. This makes no sense, so you have to hit none. My final one is the y-intercept. The y-intercepts are the easiest. You have to, again, write your answer as a coordinate point. The y-intercept means substitute x to be 0. So this disappears, this disappears, this disappears. Then your y would be negative 10 over 25. You want it in simplest form. They both have a 5 in common. And so you write down here, 0, negative 2/5. So that's how we do this lesson here. I hope you guys have a wonderful day.